Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 11th, 2025, about 2 days ago. It introduces a category-agnostic motion capture system that can take a single camera video, plus any rigged three-dimensional character, and produce animation-ready joint rotations, even transferring motion convincingly across very different species and rigs. The paper is titled MoCapAnything, Unified 3D Motion Capture for Arbitrary Skeletons from Monocular Videos. And as we will see later, the ability to drive almost any asset with just a video prompt could really change how animators and game developers create motion. Figure 1 gives the big picture. The system turns a single camera video, plus a chosen three-dimensional character, into animation that directly drives that character. The left side illustrates the input source video, while the center block highlights the 3 stages that reconstruct motion and decode joint trajectories. On the right, the top panel shows motion reconstruction, where the animated asset matches the video subject, and the bottom panel shows motion retargeting, where the same motion controls a very different creature. Figure 2 spells out how the system actually processes a video and a character to recover motion. The top block shows the reference prompt encoder, which turns the asset's skeleton, mesh, and example images into a set of joint-specific query features. The lower block illustrates the video feature extractor and unified motion decoder that convert the input video into a three-dimensional joint trajectory sequence. On the right, the inverse kinematics module takes these trajectories and outputs final joint rotations, so the animated leopard follows the captured motion frame by frame. Alright, Figure 3 shows how the predicted motions actually look compared to both ground truth and the previous Gen Zoo method. The left column contains the rendered animal clips, which set the target motions for birds, dogs, rams, and ostriches. The middle columns with blue skeletons show ground truth versus this method's reconstructions, which stay smooth and anatomically stable. On the right, the Gen Zoo skeletons often jitter, collapse, or lose limbs for these more complex skeletons. Table 1 makes the performance gap very clear. This method tracks skeleton structure much more accurately than Gen Zoo. The table reports CD skeleton, which is a chamfer distance style score that measures how closely the predicted and ground truth joint sets align in 3 dimensions, so lower is better. For both quadruped and non-quadruped rigs, the numbers drop by roughly half. That consistent reduction means more faithful, anatomically plausible motion across the entire TrueBone Zoo benchmark. Figure 4 shows that the system can reuse the same motion across very different animals, while keeping each skeleton plausible. The top row depicts the original Jaguar video frames, which define the source motion. Below, the second row visualizes the Jaguar's own skeleton driven by that motion. The remaining rows illustrate motion retargeting, meaning the same captured movement animates parrot, ostrich, and lion rigs, so gait and timing stay consistent, even though body shapes change a lot. So the big takeaway is that motion capture no longer has to be species-specific. One unified system can turn a single camera video, plus any rigged character, into clean, rotation-based animation. This opens the door to prompt-driven motion libraries for games, film, and indie creators, without expensive capture stages. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.